Now there is one limit that you should know because it comes up often in root test, which is the limit of nth root of n as n goes to infinity. This is calculated by a simple application of the L'Hopital. So let me demonstrate that. Limit n going to infinity of n to the 1 over nth power. And because it's not a fraction yet, to make it into a fraction, you use the e to the ln trick. What's that? You write e to the ln of the same thing, n to the 1 over n. Now these two are the same because e and ln cancels. If you cancel the e and ln, this just becomes the same thing. Now what's the next step? Frog over the log. This thing jumps over the log just like a frog, so that this is a limit n going to infinity of e to the 1 over n times ln of n. Now, in order to use L'Hopital's, I need this to look like a fraction, so let me rewrite it as e to the ln of n over n. Then, as n goes to infinity, ln of infinity is infinity, n goes to infinity, n is infinity, so this is indeed infinity over infinity type, in which case we are allowed to use L'Hopital's, right? So we differentiate the top. What do you get if you differentiate the top? 1 over n, yes. So you get 1 over n. What do you get if you differentiate the bottom? 1. And if you send n to infinity, you get e to the 0th power, which is 1. Okay. So given that, let's try to apply the ratio test and also the root test. Let me do the root test first because we'll be using this for two cases where we know it's convergent and which is divergent. So think about 1 over n, n from 1 to infinity. And then let's think about summation of 1 over n squared. Okay, let's start with this one. Does this converge or diverge?
That one converges.
This one converges because it's a p series with p-value 2. If it's greater than 1, it converges, right? P-value greater than 1, it converges. So this we know it converges because p is 2 greater than 1. How about this one? Does it converge or diverge? Why? You can just say harmonic. So you can also say it's a p series with p goes to 1, but you can just say diverges because it's a harmonic series. That's the idea. Now let's try to apply the root test and see what happens. Root test says that capital R value is limit n going to infinity of nth root of square root of 1 over n. There should be an absolute value, but this is already positive. I'm not writing the absolute value. Which is same as limit n going to infinity of 1 over nth root of n. What's this limit again?
1.
1. So 1 over 1 is 1. Yeah, we just did that nth root of n goes to 1, so that's 1. Okay, let's think about this case. You do the root, r equals to limit n going to infinity of nth root of 1 over n squared, which is same thing as limit n going to infinity of 1 over nth root of n squared. What's this limit? Nth root of n?
1.
Again 1, so you get 1 over 1 squared, which is again 1. So you have an example where if you apply the root test, a convergent series gives you 1, and a divergent series also gives you 1. So convergent 1 gave us 1, divergent 1 gave us 1. Which shows that, oh, indeed, if capital R gives you 1, you're not really sure if the series is going to converge or diverge, because there are examples where it converges, and there are examples where it diverges. It's just like when my doctor was seeing my allergy test results and says, oh, well, there's like 40% positive, 40% error in positive results, so she's not still sure if I have allergies. So that happens for root test. Okay? Sometimes you get false positives, right? In medical tests, just like that. In root test, if there's any kind of false positive, then we always say inconclusive, because for math, we only talk about exact results, right? So, oh, harmonic we did last time. Yeah, you missed. All right. Now let's try the ratio test. What's our AN for this case?
1 over n.
1 over n. Okay. What's AN plus 1? You're replacing n by n plus 1, right? So it's 1 over n plus 1. Therefore, what is the limit n going to infinity of an plus 1 divided by an? Well, that will be your r value. This is 1 over n plus 1 divided by 1 over n, limit n going to infinity. And by keep, change, flip, you keep the 1 over n plus 1. You change the division into multiplication. 1 over n gets flipped as n over 1, which is limit n going to infinity of n over n plus 1. What's this limit?
Infinity over infinity, so you could just...
The leading term is n and n, so you get 1. If you want to say infinity over infinity, then in that case you use L'Hopital. L'Hopital, you differentiate top and bottom, you get 1 over 1.
So, sorry to interrupt you.
Yes.
At this point where we're at now, when we do that, we don't have to say infinity over infinity type, I'm going to use L'Hopital's, right? We can, if we know.
Yeah, so, it depends on your professor. Some professors really want you to either say infinity over infinity type and then use L'Hopital's, or another method is to divide top and bottom by n. But I kind of think of that as a trivial step. So if you write from here and then just write 1 in your exam, I don't care.
Okay.
Yeah. Okay. Ratio for capital R, limit n going to infinity. Well, this one, yeah, an is 1 over n squared, and 1 over n plus 1 squared. So I'm not going to be spelling out what an and an plus 1 is, but this is going to be limit n going to infinity of 1 over n plus 1 squared divided by 1 over n squared, which is limit n going to infinity of 1 over n plus 1 squared times n squared over 1, so that if you multiply top to top, n squared, bottom to bottom, by the way, n plus 1 squared is what? That's n squared plus 2n plus 1, right? n plus 1 squared is n squared plus 2n plus 1. What's this limit?
1.
1 again. So these two examples are, again, examples that show that the ratio test gives you both 1 and 1. Okay? It's an example where one case it converges, the other case it diverges. So that's a demonstration that when capital R becomes 1, you can't say whether the test converges or diverges. You have to refer to a different test. Yes?
Could you quickly tell me what you mean by harmonic?
Oh, harmonic means like, harmonic series is like some number here, constant. And the bottom one is an arithmetic one. So if you have an plus b, if you have a summation of this sort, then this always diverges. Harmonic series always diverges.
Oh.
And this is a case where a is 1 and b is 0, and c is 1. So 1 over n is an example of an harmonic series.